Well. So you want to learn about the history of AI and computing, right? So buckle up and sit on down because this is gonna be a long ride. It all started in 1791 when a genius named Charles Babbage was born. Wait, no, that doesn't sound right. Let's go way back in time. Most people think AI and computing are modern ideas, but the concept of thinking machines has been around for centuries. Every technological breakthrough starts as a wild idea, and humans have been fantasizing about artificial intelligence since ancient times. The ancient Greeks had the story of Talus, a massive bronze statue built by the god Hephaestus to protect an island state. This thing was, by all definitions, a living robot. Over in China, there's the legend of Yan Xi, who supposedly created a fully functional automaton. These stories weren't just random myths, they show how obsessed humans have always been with the idea of creating mechanical life. Fast forward to the 12th century, and we get Al-Jazari, a Muslim scholar who designed mechanical devices that mimicked human actions. Meanwhile, in medieval Europe, philosophers like Roger Bacon started imagining machines that could think and reason like us. But the real game changer, the Renaissance. This was when minds like René Descartes and Thomas Hobbes started comparing human reasoning to machine computation. Their ideas laid the foundation for philosophy behind AI. Then came Gottfried Wilhelm Leibniz, who not only formalized binary math, more on that later, but also built the first mechanical calculator. That was the spark, the first real attempt to make a machine that could think. Alright, here's something to blow your mind. Your phone, your PC, even modern AI, all of it traces back to textiles. Textiles? Yeah, fabric and rugs. Today we store data on silicon flash memory, things like this USB flash drive. But back in the day, computers stored data on paper. How? Let's rewind to 1725 when a French inventor named Basile Bouchon revolutionized the loom. The loom is an ancient textile machine which we still use today. He developed a system where a sheet of punched paper controlled which threads were lifted to create patterns. Sounds irrelevant? Wrong. This was the birth of programmable machines, a device that could read instructions from an external source. A few decades later, another French inventor, Jacques de Vaucanson, improved on this idea. And finally, Joseph-Marie Jacquard perfected it, creating the famous Jacquard loom. I'm pretty sure I literally butchered those names, but let's just move on. His loom used punch cards to control the weaving process, meaning you could program it by swapping out different cards. And this is where computers come in, because in the end, all modern computing comes down to one simple idea: binary. Either something exists or it doesn't. Either there's light or there isn't. Either something happens or it doesn't. 1791. While France was busy revolutionizing the world, over in the UK something else was brewing. A genius named Charles Babbage was born, and he would go on to connect punch cards to something far greater. Babbage took one look at Jacquard's loom and thought, wait a second, this is basically binary. If a thread gets lifted, that's a 1. If it doesn't, that's a 0. Inspired by binary math formalized by Leibniz, whom I mentioned before, Babbage had a brilliant idea. What if I build a machine that can be programmed to do logical tasks and calculations using punch cards? And so he conceptualized two revolutionary devices: the difference engine, which could automate complex calculations, and the analytical engine, which was basically a mechanical computer a century ahead of its time. Babbage even worked with Ada Lovelace, who wrote the first algorithm meant for a machine, making her the world's first computer programmer. And here's the tragedy. These machines were too advanced for their time. They were massive, complex, and expensive. No one wanted to build them. Babbage died in 1871, never seeing his dream come to life. Ironically, just a few years later, punch cards were adopted for something much less exciting: counting people. God damn it. The US government conducts a census every 10 years, but back in the 19th century, this was a nightmare. The 1880 census took 8 years to process. By the time they were done, the next census was already overdue, and America's population was growing by 30% each decade. So this problem was only getting worse. People were like, what do we do? Hire more people? Enter Hermann Hollerith. This German American inventor came in and said, hey guys, I built something that might help. It's called the tabulating machine. His machine used punch cards to process data mechanically rather than by hand. The result? The 1890 census, despite a massive population increase, was completed in 6 years instead of 8. It was a turning point. Governments, corporations, and accountants everywhere started adopting punch card machines. And guess what? That created an entire industry, one dominated by a little company called IBM. 1937. While the world was obsessed with punch cards, an American researcher named George Stibitz had a different idea. He wanted to build a calculator that ran on electricity instead of mechanics. One night in his kitchen, he put together a crude little invention using Boolean algebra, which is a mathematical logical system based on binary. He called it Model K because he built it on his kitchen table. It was basic, but it proved the point. Electronic computation was the future. Bell Labs took notice and put Stibitz in charge of a project to build something bigger. The result? Model 1, a large-scale electromechanical calculator. But it had a problem. It relied on switches that physically flipped on and off, which made it slow and clunky. Then in 1941, two scientists named John Muckley and J. Presper Eckert, I guess I butchered some names again. Okay, moving on. These guys set out to build something better. They designed ENIAC, the first fully electronic general-purpose computer. This thing was a beast. It took up 18 square feet, or 170 square meters. It weighed around 30 tons, and it had 18,000 light bulbs. Basically, a special type of light bulb called the vacuum tube. And, wow, this thing required 150 kilowatts of power, which means that this thing guzzled up on so much electricity that they had to put some kind of a dedicated generator on it. But the good point of this machine was that it could perform 5,000 operations per second. For context, Model 1 could only do one operation per second. In just 6 years, scientists made computing 5,000 times faster. The secret? Ditching those slow mechanical switches and going fully electronic with vacuum tubes. But there was a problem. Vacuum tubes were some kind of specialized light bulbs. They burnt out constantly. ENIAC was a nightmare to maintain. Scientists knew they needed something better. And so the race to improve computing began. Soon every lab was experimenting with new ideas. There was EDVAC, ORVAC, ETSAC, and Keserac? Okay, I don't know how to pronounce that name. Moving on. And then suddenly out of nowhere came a new name. UNIVAC. And that is where things really start to get interesting. Here's something crazy to think about. ENIAC, a machine that filled an entire room and consumed massive amounts of power, is now outperformed by a cheap pocket calculator you can buy at a local shop. And these things are powered by small batteries. Alright, so we've got these massive computers like ENIAC taking up entire rooms, guzzling electricity like a medieval feast and lighting up like a Christmas tree with thousands of vacuum tubes. It was impressive. But let's be real, nobody was fitting one of these bad boys in their office, let alone their home. So what now? Well, the next logical step was to make computers smaller, faster, and more practical. Enter the 1950s, where companies and organizations took on the challenge of taming these electric beasts. The first real breakthrough? UNIVAC. Developed by the same duo behind ENIAC, UNIVAC was the first commercially available computer in the United States. Unlike ENIAC, which was built for military use, UNIVAC was designed for business and government applications. What made UNIVAC special? Well, for starters, it ditched those slow punch cards in favor of magnetic tape storage, a huge leap in data processing. It also managed to perform 13 times faster than ENIAC while having less than a third of its vacuum tubes. Oh, and let's not forget the moment when UNIVAC truly made a name for itself. During the 1952 US presidential election, CBS used it to predict the outcome, and despite skepticism, it correctly forecasted Eisenhower's landslide victory long before human analysts did. That was the moment people realized, hey, maybe these machines can actually outthink us in some areas. But UNIVAC, as revolutionary as it was still huge. While being much smaller than ENIAC, UNIVAC was still half as heavy, and this is where the true shrinking act began. Companies like IBM, General Electric, and RCA jumped into the game, trying to outdo each other in making computers smaller, faster, and more accessible. The real game changer? The transistor. In 1947, a while before UNIVAC was invented, Bell Labs, the same institution behind Model 1, invented the transistor, changing everything. After getting commercially used in computers in the mid 1950s, the transistor replaced the bulky, power hungry vacuum tube. Suddenly, computers became smaller, more reliable, and way more efficient. It also didn't burn out, unlike vacuum tubes. By the late 1950s and early 1960s, second generation computers powered by transistors were taking over, paving the way for what would eventually become the personal computer revolution. But that's a story for another chapter. Alright, so we've shrunk computers down from room sized behemoths to something more manageable. But let's take a step back. We're in the 1950s and 60s now, an era of radical change, not just in technology, but in ideas. This was when computers stopped being just giant calculators and started creeping into the realm of intelligence. That's right, folks. Artificial intelligence was about to take center stage. But first, we need a little groundwork. The invention of the integrated circuit in 1958 by Jack Kilby and Robert Noyce changed everything. Instead of wiring together thousands of individual transistors like some kind of electronic Frankenstein, now entire circuits could be built on a single piece of silicon. This meant faster, more reliable computers, which in turn meant computers that could process more complex tasks. And with that extra processing power, well, why not try teaching these machines to think? Enter the age of artificial intelligence, a concept that had been brewing for centuries in the minds of philosophers and science fiction writers alike. The term artificial intelligence itself was coined in 1956 at the Dartmouth Conference, a legendary gathering where pioneers like John McCarthy, Marvin Minsky, and Claude Shannon sat around and basically said, hey, can we make a machine that thinks? Of course, computers back then weren't exactly the sharpest tool in the shed. Early AI was a lot of if this, then that kind of like logic. People wanted computers that could learn, adapt, and maybe even outthink us one day. That sounded exciting to some people, and terrifying to others. Science fiction had already been warning us about the dangers of thinking machines long before we even built them. Books like I, Robot introduced the famous 3 laws of robotics, trying to get ethical boundaries for AI before it even existed. Meanwhile, Harlan Ellison's I Have No Mouth and I Must Scream took a much darker approach, imagining a world where an omnipotent AI tortures the last remaining humans for eternity. The message: AI could be the next step to human evolution or our doom. But fear didn't stop progress. AI research was booming, with programs like Eliza, an early chatbot that mimicked human conversation, and this thing which I can't pronounce, a system that could understand and manipulate objects in a virtual world. Sure, they weren't HAL 9000 or Skynet, but they were proof of concept. Machines could imitate intelligence, even if they weren't quite there yet. And let's not forget the cultural side of things. Hollywood was catching on too. In 1968, the movie 2001: A Space Odyssey introduced HAL 9000, a calm, logical AI that just so happened to have a homicidal streak. It wasn't just a movie villain, it was a question. What happens when machines become too smart for their own good or ours? So here we are. Computers are getting smaller, AI is creeping into reality, and the world is starting to realize that this whole thinking machine thing might be more than just a sci fi fantasy. But AI still needed more power, more speed, and more accessibility. And that's where the next revolution begins: the rise of home computers. All right, so we've seen the birth of AI and how computers went from big things into smaller things, right? But let's be real. Your average Joe still wasn't exactly booting up a machine at home to check emails. That was about to change. Enter the 1970s, the dawn of the personal computer era. This was the time when computing stopped being just a playground for government agencies, universities, and big corporations. It started sneaking its way into homes, offices, and eventually our pockets. The big breakthrough? The microprocessor. In 1971, Intel dropped the 4004, the first commercially available microprocessor. And suddenly, all those clunky circuits and complex processors could be crammed into a single tiny chip. This wasn't just an upgrade, it was a game changer. Now, computers could be smaller, cheaper, and more efficient. Companies like Intel, AMD, and Motorola jumped into the race, each trying to outdo the other with faster and more powerful chips. By the late 70s, we had the first wave of personal computers. The Apple I, which was made by these two legendary fellows, Steve Wozniak and Steve Jobs. We also had the Commodore PET and the TRS-80. These weren't just nerdy toys, they were the beginning of a revolution. Then came 1981, when IBM released its personal computer, setting the standard for what computers would look like for decades to come. And let's not forget the graphical user interface. Apple's Macintosh in 1984 made it clear that clicking on icons was way more fun than typing commands. But computers weren't just becoming more powerful, they were becoming creative tools. The 70s and 80s saw the birth of digital art, video editing, and even the first 3D model in 1972. Suddenly, computers weren't just for crunching numbers, they were for making things. The first image editing software started popping up, sound engineering went digital, and video game developments began taking off in a way that would reshape entertainment forever. By the 90s, the digital revolution was in full swing. Photoshop changed the way we saw images. Non-linear editing software made filmmaking accessible, and sound engineers could now create entire symphonies on a single machine. And then came the internet. While it had been brewing in the background since the ARPANET days, the 90s made it explode. Websites, emails, and online chat rooms connected people in ways never seen before. Home computing wasn't just about work or entertainment anymore, it was a gateway to the world. By the end of the 90s, the personal computer had become a household staple. The world was digital, and there was no turning back. But as computers became more accessible and powerful, so did AI. The foundation had been set, and the next step, teaching computers not to just process information, but to think. And that is where things get really interesting. Welcome to the 21st century, where computers are no longer just tools, they've become an extension of human intelligence, creativity, and depending on who you ask, maybe even consciousness. The new millennium didn't just bring flying rumors of Y2K disaster, it also kicked off an era of rapid digital evolution, pushing computers, AI, and robotics into realms that once belonged to science fiction. Let's start with raw power. If the 70s to 90s were about making computers accessible to the masses, the 2000s onward were about making them powerful enough to reshape the world. Processor technology skyrocketed. Intel and AMD waged war in the CPU battlefield, releasing monstrous chips like the Intel Core series and AMD's Ryzen lineup, each iteration getting faster, more efficient, and packing more cores than ever before. GPUs, once simple graphics accelerators, became computational beasts, birthing the modern AI revolution as NVIDIA and AMD pushed the boundaries of parallel processing. But here's the kicker. Moore's Law, that old prophecy predicting the doubling of processing power every 2 years, started showing its cracks. As transistors approached atomic scale, companies were hitting a wall. More power meant more heat, more inefficiencies, and new physical limitations. The industry started looking for alternatives: quantum computing, neuromorphic chips, and 3D stacked processors, anything to keep the gears turning. Meanwhile, robots went from factory workers to household names. Boston Dynamics' agile machines danced and leaped, Japan's Asimo walked and talked, and self driving cars moved from wild fantasies to realities. Fueled by companies like Tesla and Waymo, AI driven robotics weren't just about automation anymore. They were about interaction, adaptation, and even companionship. And speaking of AI, oh boy, did it explode. The 2010s saw the rise of deep learning, where neural networks got so good at processing language, images, and data that suddenly computers could think in ways humans never expected. OpenAI's GPT models brought AI powered chatbots into the mainstream. DALL-E and Deep Dream pushed the limits of AI generated imagery, turning raw code into surreal masterpieces. Google's DeepMind conquered Go, beating human champions with moves that even the grandmasters couldn't comprehend. AI wasn't just improving, it was evolving, learning, and in some ways, surprising even its creators. And just about 3 weeks ago, China released Deepseek, which will heat up the competition. Of course, this wasn't all sunshine and rainbows. Ethical concerns grew louder. Who controls AI? What happens when it's too powerful? Writers feared being replaced. Artists debated the soul of AI generated art. And governments scrambled to regulate what felt like an inevitable future. And as we stand here at the frontier of artificial general intelligence, quantum computing, and who knows what's next, one thing is clear. This isn't the end of the story, it's just the beginning. So, what comes next? Well, that's a question we may not have the processing power to answer yet. Where did we come from and where will we go? Our ancestors went through centuries of progress to bring us to this moment. And now, almost everything around you is in some way a computer. Your TV runs apps, your dishwasher connects to Wi Fi, and your car locks features behind its subscription. Give it a few more years, and who knows, maybe you'll have to pay a monthly fee just to keep your own organs running. Technology isn't just something we use, it's something we rely on. And every year that dependence grows, AI is taking over tasks once thought to be uniquely human. Let's be honest, it's already replacing jobs. But whether you like it or not, this seems to be a future we cannot escape. In fact, if you haven't noticed yet, about half of this video's script was written by ChatGPT, and who knows, maybe you're not even looking at a real person right now. Jokes aside, this project took a long time to put together. So if you stuck around until the end, why not drop a like and subscribe for more? I'm PJ, your host, and I'll see you next time. Ciao.